Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solution to the first three problems of CodeTON round 3, which was written for Division 1 and Division 2. So let us quickly start with the first problem. So this particular problem says that we have been given an array or a permutation of size n, and like each element, obviously if it is a permutation, each element from 1 to n appears exactly once. Right, so all the numbers would be unique, and we have been given three indices I, j, and k. Then we have to tell the only operation that we can perform is choose these three indices, and if I a of I is greater than a of k, then we can do a of I is equals to a of I plus a of j. Otherwise, we can swap a of j and a of k. So let me just write it down somewhere. So a of I is greater than a of k. So if a of I is greater than a of k, then we will do a of I is equals to a of I plus a of j. Otherwise, we will do swap a of j and a of k. Right. So if the first element, if the ith, if we are taking I, j, and k, if a of I is less than or equal to a of k, then we can choose any j between I and k, and we can swap it with k, right? So obviously if this is a permutation, you'll observe that if the first element is the smallest element, and in this case it could be 1, right? If the first element is the smallest element, then we can choose any two indices here, right? We can choose any two indices and swap them. So essentially, if the smallest element is at the first position, then we can rearrange the rest of the elements in any way we want, right? Because we can choose any two indices and we can swap them. So for example, if this was 1 here and this was 3 and this was 2, right? If I choose these three as I, j, and k, then obviously I can choose this particular 1 and 2, and 1 would be less than or equal to 2. Now I can choose j as 3 and I can swap these two elements, right? So this is 1, 2, and 3. So if the smallest element is at the first position, then I can rearrange the rest of the elements in any order, right? And if I do this, I can essentially form any type of sequence I want. And in this case, I wanted an increasing, non-decreasing sequence. So I can form easily when the smallest element is at the first position. Now what happens if the smallest element is not at the first position? Now in this particular case, you can only do this particular operation, right? For example, there was some element x and this is not the smallest element, then it for at least like for some position there might be an element less than x. For example, this is 1. Now the only operation you can do is you can increment x with you can add some value a of j to it. So it will not help us because it will just increment the value of x even more, right? So it is not going to help us in any way, and we will not reach our solution. So the only solution to this problem is when we have the smallest element at the first position, only then we can form a non-decreasing sequence. So in the answer we just have to print yes or no, and let me just show you the code. So this is what I've done is I've taken an integer n and I take a vector of size n as input. So I just check if the 0th element is equal to the minimum element of from the vector v, right? If this is equal, then the answer is yes, otherwise the answer is no. So this would be the solution to the first problem. Now moving on to the second problem of today's contest, which is maximum substring. Now this particular question says that a binary string is given, which is obviously consisting of zeros and ones. Now for any non-empty substring, right, from S, so what we can do is if we say that x is the number of zeros and y is the number of ones, then the cost of the substring is x into y if both are non-zero, x and y are non-zero. It will be x square if y is 0, and it will be y square if x is 0, right? So obviously if you are choosing a non-empty substring, both of them cannot be 0 at the same time. Either one of them can be 0 or both of them can be non-zero, right? And we have been given the binary string s, so we just have to find the maximum possible cost among all the substrings of the given string s, right? So basically we have to choose substrings from the string and we have to tell the maximum cost that can be of that substring, right? So obviously there is one very important observation. Let me just write it down. So if I have been given a string of zeros and ones, right, and I have some values x and y, right? So x is the number of zeros and y is the number of ones, let's say. So if I want to include both of ones and zeros in my answer, so it is always better to take the whole string s as the substring that we are asking for, right? If this is the s string that we are given and I want to include both zeros and ones in my answer, then why not take the whole string? For example, if I just take this particular string substring, then the number of zeros is 2 and the number of ones is 2. So the answer in this case, the cost will be 4. But if I take the whole string as input, the number of zeros will be 3, the number of ones will be 3 and the answer or the cost will be 9. So if I am including both zeros and ones, then it is always better to take the whole string, right? So this is our first observation. Now the second thing is, now the second case is when I want to include only zeros or only ones, right? So for this case, we can just find the longest contiguous sequence of zeros and the longest contiguous sequence of ones in the string, right? For example, if I have 0 1 0 0 1, so here the longest contiguous sequence of zeros is of size 2 and the longest contiguous sequence of ones is of size 1, right? Because there are two zeros present here and one is only present single time every time we see it, right? So we can just take the longest contiguous sequence of either zeros or ones and we can save it. So my final answer would be the longest sequence. So let us denote it as max 0. Max 0, let us talk about max 0. Max 0 would be the longest sequence of zeros present together. Max 1 would be the longest sequence of 1 present together. Count 0 would be the count of zeros in the original string and count 1 would be the number of ones in the original string, right? So my final answer would be max 0 square, because obviously if they are all zeros, we just have to do x square. If x is the number of zeros and all the values present in the string are zeros only, there are no ones, then we can just do x square. Then again similarly, if all ones are present, then we can just multiply it by itself, that it is also square. Now if there are both zeros and 1 present, then we can just multiply them together. So my final answer would be the maximum value of the from 3 of these values. So the maximum among these values would be my final answer, and I have considered all the cases when I am taking zeros and ones both. Otherwise, I am taking only ones or I am taking only zeros. There cannot be a case when I don't take any of them, because I have to choose a non-empty substring, right? So my final answer would be the maximum of these three values. So let me just show you the code. So I've taken four variables: count 0, count 1, max 0 and max 1, and they do the same function and they do the same thing as I've explained. Then count 0 is the number of zeros in the given input string, count 1 is the number of ones in the given input string, max 0 is the maximum number of zeros that are present together in a contiguous fashion, right? And max 1 is the number of ones that are present together. Now I just take the input n and s. I just check for the first character. If it is 0, I just increment count 0 and max 0, and otherwise I just increment count 1 and max 1. So I just run a loop from 1 to n. Every time I encounter a 1, I just increment count 1, otherwise I increment count 0. Now I just check if the current element is not equal to the previous element. That means a contiguous sequence has been broken at this particular point, right? So I just check if the last element was 1, then I update the value of max 1 as maximum of max 1 comma current. So current is the length of the current segment, right? Else max 0 is equal, if the last element was 0, then max 0 would be equal to maximum of max 0 comma current. Now I initialize again current with 1 and I just continue to the next iteration. And if I don't enter this loop, I just increment current, right? So current is storing the length of the current segment. So after this loop is done, I just check for the last time. If the last element was 1, then I just store the value of max1 as max of max1 comma current. Otherwise max0 is equal to max of max0 comma current. Now at the end, I just find the maximum value of max0 into max0, max1 into max1, and count or count0 into count1. So this is all what I have explained earlier, and this would be the final solution for the second problem. Now moving on to the third question for today's contest. So this is complementary XOR, and this particular question says that we have been given two binary strings and of length n. So basically both of them are binary strings and they are of length n each, and we want to make all the elements of both the strings equal to 0, right? And we can perform like this particular operation only. We have to choose two indices L and R such that they are in the range 1 and n included, and for every I that is in the range L and R, we have to invert the bits of the string A in the range L and R, and in the range not L and R, that means from 1 to L till less than L, and from R plus 1 to N, we have to invert the bits of the string B. So let me just show you an example first. So if I have two strings 1 0 0 1 1 and something like this, right? So if I choose this particular region such that L is this particular position and R is this particular position, so for all, so let me just notate that this is A and this is B. So in the whole region between L and R, I have to invert all these bits in A. So in the next step, the A would look like something like this. So A would be something like this, right? I have inverted all the bits in this region. And for B, I have to invert all the bits that are not present in that region. So in this case, it would be like this. This would be 0, right? So this would be the result of choosing L and R in this way, such that all the bits lying in the region in A would get inverted and all the bits lying outside the region in B would get inverted, right? So this is how we define a single operation. Now we have to tell whether there exists a way or a chain of operations such that we can make all the bits of both of the strings A and B, all of them 0, in at most n plus 5 operations, right? So we are allowed to do n plus 5 operations, no more than that, and in that particular operation we have to make all the bits of string A and B equal to 0, and if we cannot make it, we just have to print no. So this is our like the whole question. We have not been limited. We don't have to print the minimum number of steps. We just have to print whether this is possible, and if it is possible, we just have to print the steps as well. So if you carefully observe, then then I will discuss two base cases. So the first base case is when, let me just take a string of size 4. So the first base case is when the answer is yes. So in this case, the answer would obviously be yes because they are already all zeros. Let me discuss one more case where the answer will be yes. So if A is equals to 0, all 0, then the answer will be yes only in this particular case. Why this case has the answer yes? Let me just show you. So if I choose this particular order, then what I can do is I can select the first element, right? So if I choose the range L and R from 1 to 1, then the change would look like something like this. This changes, rest of it remains same, and for B this remains same and all the other changes, right? Now I choose the range from 2 to n. Now so in this case I just took the range from 1 to 1. In this case I'll take the range from 2 to n, and A would look something like this now, 1 1 1 1, and B would look something like this would be 0 0 0 0, right? And then I can just take the range 1 to n, and then my A string would look like this and B would look like this. So we see from this particular state this particular state, I can reach this final state in 3 steps. So this is step number 1, this is step number 2, and this is step number 3. Right. So it is possible to reach this final state in 3 steps. Now, if the value of A is all zeros, we cannot find any other string B other than this string such that we can reach the final answer. Right. So if A is all zeros, then B have to be this string consisting of all ones. This is just a simple observation, and there is no like definite proof for this, but you can just find it by running through some cases, right? So after we have found this, then we have to figure out a way to make all the bits of A equal to 0, right? So if A has some ones, right, and B has some ones also, so it has some value. So we just have to find some way to make all the bits of A equal to 0, right? So you will observe that no matter in what way we change the bits of A to 0, the resultant string B would always be the same, right? If I want to make all the bits of A equal to 0, in no matter in what way I change, the resultant string B will always be the same. So what I essentially do is I just take each of the bits of A and turn it to 0, right? If this is 1, I want to turn it to 0. If this is 1, I want to turn it to 0. And again, similarly for all the bits, I just turn it to 0 by, so if the ith bit in A is 1, if the ith bit in A is 1, then what I do is I just perform the operation on the range I comma I, right? So in this case, what will happen is the operation will be performed on this particular range, and the ith bit will be inverted and it will become 0. So once it becomes 0, I also have to take care of the operations that are being performed in B. So for example, if I is some position like this, right? Now in this particular case, then the ith bit in A would become 0 and all the bits in this range in B would get inverted, right? So I just have to check by, like, I can just loop through the string A and convert all of those ones into zeros and just store this particular information for B, and at the end I will just check whether the string B is consisting of all ones or not. If it is not consisting of ones, then the answer would be no, obviously. So how does this work? For example, if all the bits in A is 1, then converting them all to 0 would take n steps, right? And I have already shown that if this is all 0 and this is all 1, then converting from this state to the final state like this takes 3 steps. So again, we will be able to do it in n plus 3 steps at maximum, right? So how do we check whether the final string B is consisting of all ones? So for this, we can just perform some simple range query operations, and we can just store how many times the jth bit in B has been inverted. For example, if initially the jth bit in B was 1 and it has been inverted even number of times, right? So if it is inverted 1, then it becomes 0. If it is inverted again, it becomes 1. So if it has been inverted even number of times, it will still be the same bit. But if it has been inverted odd number of times, the bit would change. From if it was 1, it will become 0. If it was 0, it will become 1. So this is the simple logic that we have. So we will use some range query to find out the resultant string B, and we will just compare whether it is equal to all ones or not. If it is not equal to all ones, then we'll just print the answer no. Otherwise, we'll just print the final answer. So here I've taken a string, an integer n, and two string inputs a and b, and I just this is my build function for the range segment tree. So we don't actually need to look at the code for the segment tree. You can just like take it as a black box, and you just need to know what these functions actually do, and you don't have to worry about the code of the segment tree. You can find it anywhere online on like CP algorithms or some other website, right? So I just add this question mark to the string a just for the sake of like consistency and using one based indexing. So I just add this particular question mark to both of the strings for one based indexing, right? So I have taken a vector which will be storing my final answer. So this would be my result, and I just run a loop from 1 to less than n plus 1. Now if the ith bit in a is equals to 1, then I need to change it. So right, what I'll do is I'll just push this particular value into my result, that is I comma I. Now, if I is greater than 1, I'll just update my segment tree. And what I'm essentially doing is, in the range from 1 to I minus 1, I'm just incrementing all the values by 1. So it will, and in the end, I will have that all the values at the current index was incremented X number of times. So if I have this value of X, I can determine whether the ith bit or the jth bit, whatever, of B should be changed or not. If it has been incremented odd number of times, then that bit will be changed. Otherwise, it will not be changed. Right. So now what I do is I just check for all these values, and again, if I is less than n, I'll increment all the values in the range from I plus 1 to till n by 1. Right. So I'm just incrementing that this bit has been changed one more number of times. Right. At the end, what I'll do is I'll just loop through from 1 to less than n plus 1, and I have calculated the value of dx. So for the ith position, I just check if it has been incremented odd number of times, that is dx and 1 is true. Then if bi was 0, then I'll change it to 1, otherwise I'll change it to 0. Right. So again, I just take string x and y, and I started with question mark, and I just store all zeros in x and all ones in y. Right. So x will look like question mark 0 0 0 0 and n number of times 0, and y will look like question mark n number of times 1. So question mark is just for the sake of consistency and using one based indexing. Right. So I just check if b is equals to x, that is b is equals to all zeros, all the number all the characters in b are equal to 0. I just print yes, and I just print result dot size and all the elements in the result vector. If b is equals to y, that means all the elements in b are 1. Then I just use these three steps that I've already explained. I just use it once for 1 comma 1, then 2 comma n, then 1 comma n. After these three steps has been performed, I just print my answer yes. I print the size of result, and I print the result vector itself. Right. If both of these conditions are false, I just print no, and this would be my final answer. So I hope that you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.